this is the thing, like, is it actually perfect? Is the distribution perfect? Well, like the answer is like, if you're using the default configuration of Ceph, the answer is no. And that's because there's some technical reasons why, but we'll probably share, I mean, we'll have to at some point share a slide, or maybe in the post notes. And we have shared in different talks in the past, like how to configure Ceph's balancer internally to get a better distribution. And we'll share those. We'll share probably one screenshot at some point today. But I think like maybe a good thing to go into, Brian, before we can go into like Upmap-remapped and things like that, we should show how, like, what is Upmap? What is this whole thing that we're talking about? This like silly jargon Upmap. Is that, are you able to show Brian some like how?
Yeah, I could share
how the whole
like
mechanism works.
Yeah, I could share a cluster that we have.
Yeah.
All right. Can you see the screen here?
Yeah.
All right.
So we can take maybe Rushali, you can stop you don't need to share that slide anymore. So everyone will get the thing. Yeah.
All right.
Perfect.
So let's just list our PGs for example. That's FTPGLS. And this is a cluster that just has like replica, like 3x replicas. So there's in each placement group, there's like an up and an acting. And this describes the 3 OSDs that are in that placement group. So host base of 13, 35, and 31 should all be on separate hosts. So if you do like Ceph OSD 9, 13. See, that's on Ceph 1, 5, Ceph 5, and then 31. So 1, 3, and 5. But say you wanted to move like one of these, like maybe like.
What is that? What are you showing, Brian? What are those 2 columns?
Those 2 columns? I said that was the up set and the acting set.
Oh, and acting is what again? Sorry.
Acting is acting is where the data is at now, and up is where it wants to go. So like say you are balancing a cluster and it wants to move the data from 31 to 30. This would be active remapped, like backfilling. So I would say, well, let's actually just create an upmap to like make that happen. So an upmap is kind of like something that goes over, like these are determined by the crush calculation. But upmaps are kind of like small corrections on top of that crush calculation. So what you could do is say Ceph OSD PG upmap items. This is what the balancer does for you automatically. But you would give it like the PG number, and then you would say the source, so I want 31, and let me actually look at the cluster to make sure I just like move it properly. So 31 and 30 are on the same host, so that's going to be legal, since I don't know, it won't violate crush rules. Yeah. So I want to move 31 to 30. So that's all we would have to do, is just keep the PG and then source destination. If we watch, this should also go into active remapped backfilling. And then give it a second. There we go. Now if we do a PGLS, we could see it's currently on 31, it's moving to 30, and it's actively backfilling. Yeah. And this actually, this column here shows you how many objects are, and this is how many are left to backfill. So that last one should keep dropping.
Yeah, and that's why in the end, like Sage called it Upmap. It's like in the name comes from in the set of OSDs that we call up, like map this number. If this number appears, replace it with this number.
Yep. And say if you wanted to do another one, like say you wanted 35 to go on to 36, you would just do another set, like, so it works like that. So source destination, source destination. So now we should be able to watch that PG again. So hasn't appeared yet. There we go. So 31 is moving to 30, 35 is moving to 36. And that's, yeah, that's basically how Upmap works, but the balancer makes that much easier to do.
So this is like, so Upmap was invented as a way, I mean, at some point in the mid 2010s, I don't remember exactly what year, we had tried before, like in developing Ceph and trying to make all the data kind of like perfectly the same on all the disks. We had tried we tried a few other ways to do this before that. We tried, there's a thing, people might see something like reweight by utilization. There's a command like that. And oh boy, there's a few things like that we tried. And all of them seemed like good ideas at the time, but none of them really ended up working that well. And then eventually Upmap was kind of like, in a kind of funny way, it was like, we give up and we're going to stop trying to be clever with like math. And we're just going to invent a way and stuff to like force data to be on an exact OSD. And using that mechanism, now we can perfectly move the data to where it needs to be and to make all the OSDs have the same space. Yeah. So that's a good demo, Brian. There's a question from Jared, and like one is will the second half of your question, we'll show it. We'll get to that in a moment. Jared is asking, let's see if it's a good time now or later to answer Jared's question. What do I need to do in a modern technical to ensure optimal Upmap balancing storage efficiency? Okay, that's a good, maybe I'll share. Do you have the balancer enabled like perfectly on your, perfectly, do you have like with Ceph config, do you have like a good manager balancer config on this cluster that you're logged into now?
I haven't actually checked.
Because the basic, there is a, like, personally I have, and probably Brian, like people that have been, tuning balancers for a while, like we have our own favorite, like set it and forget it configuration. Mine looks like this. I can just very quickly share if that's okay. Jeepers, how do I lost the share button. I can't share. Oh, I'm not allowed to share. That's interesting. No sharing allowed.
I'm going to change that in just a moment.
That's okay. Yeah.
I think I just fixed it.
Oh, cool. Yeah, I got it. So this is it. And this is the kind of thing we'll show and we'll send as follow-up material. And we've shared this a few times. And if you go onto the Ceph documentation for the balancer, like you'll find all of these things explained. But these are the important points. Actually, so first of all, like when you say like Ceph balancer on, that literally just sets this top option. So you don't have to manually do that. The second two options there, it's like, when is the balancer active? And like, just pick some times that are good for you. Maybe you can let it run all the time, but this is just an example to show that you can control when Ceph is, which time of day. You can also do which days of the week that the balancer is doing things. The mode, that's like, actually, you don't have to, that's just, you make sure you're using that one for now. There's also in new Ceph, there's an Upmap read mode. Personally, I haven't explored that one extensively, but so I would like, being kind of conservative with things, like I would use like what's there on the screen, but there is some new, more advanced features that might also help. This, I would say the last two options are the main ones. So for Jared, like make sure that you have this Upmap max deviation value set to 1. And then this value at the bottom, okay, it's actually not exactly my preferred, depends on the size of the cluster. This is the default value. And this is just, this 0.05 with a lot of trailing zeros is meant to be like 5%. And what that is it's a throttle. It's like how aggressive do you want the balancer to be in order, like while it's trying to move data around. And this is saying like it's going to allow up to 5% of all the data in the cluster to be in data, in flight, moving around while it's balancing. That's a lot. That's actually for a large cluster. That's quite a heavy. Like that's like kind of full gas. So I usually tune that down to maybe 1% or sometimes even 0.5%. Depends on the size of the cluster. But yeah, this is it. Like it's pretty simple. So for Jared, like really the key one is this like upmap max deviation. And so just note that. So I will, Brian, maybe the question here is for you. This PG upmap items are permanent. That's a good question. Are PG upmap items permanent? When would they be removed? Are they ever removed automatically, Brian?
Yes. When an OSD is marked out, all the upmaps that involve that OSD are cleared out.
Mm-hmm.
Which isn't necessarily the best behavior, but like it should just remove the mappings.
Yeah. And what's the purpose of RMPG upmap items?
That is just to clear an existing upmap for a placement group.
Yeah, because what happens if you can you just replace a PG upmap item by running PG upmap items again? Or do you have to remove it first and then re-add it?
You can run it again.
You can run it again and it'll replace it. Yeah. We usually use the RMPG upmap items because we can't, it's like used by the tools that, so the balancer and other tools that we have like Upmap-remapped and maybe something secret that we'll show in a minute. Slight teaser, non-spoiler alert. Like in order to figure out and like compute what the distribution should be, sometimes you have to remove the upmaps that are there, the upmap items entries, so that you can see the output of Crush. Okay, Crush thinks the data should be on OSD 31. Okay, now I know like I can like move it somewhere else. Like it's something like that. That's why that's one reason why we sometimes need this tool, RMPG upmap. But it's a very like low level tool. Everything that Brian has showed here, like this is meant to explain what is upmap. So to understand the concept, really this is just like it's kind of a low level Ceph feature that just allows, it's basically a developer tool that allows developers to write tools to move data around in normal daily Ceph operations. The intention is that you should never have to know any of this stuff. Yeah, but this is somehow like a deep dive, right? To help you think of maybe some other tools or other features. Okay, is it a good time to show Upmap-remapped?
I think so.
Halfway through the hour? Yeah, okay. So let's go into Upmap-remapped. And this comes somehow, maybe we can have the context of once as a question.
Okay.
He's basically changing and then I think you can give I think you have a demo prepared, right? But like when we inject it, he injects a new Crush map and he runs Upmap-remapped and the balancer then kicks in. Why is the balancer kicking in? Yeah, I mean, I'll answer the question actually directly, but then I think you can probably, Brian, show more clearly exactly what Upmap-remapped is doing. But the very specific reason in your case, Wannes, of you're injecting a Crush map and then you're running Upmap-remapped. Okay, let's assume here it's a very fine detail, but let's assume that when you injected the new Crush map, you are changing the failure domain from host to chassis. Yeah, so that's actually a very special case. That transformation that you described is, and I'm assuming is chassis. Can you actually write in the chat? Is chassis are hosts in a chassis or are chassis in a host? Just I want to understand.
In my experience, usually 4 hosts in a chassis or something.
Right. Yeah, so exactly. So what you're trying to do, so the moment that you inject that change from host to chassis failure domain, you now have a bunch of data that is like breaking the rule of the failure domain. Because previously you had, let's say, maybe you have suppose you just have one pool and it's 3x replication, and you with host based failure domain, you'll have maybe the data across 3 hosts, but all within one chassis. Some of the data will be like that. The moment that you inject that failure domain of chassis, like the new crush map is going to actually change all of the PGs so that none of them will have all 3 of their parts within one chassis. So just by the rule of your crush rule, the MON and like the OSD maps that will be generated are going to be, and PG maps are going to like move the data out. And there's actually no way in current Ceph, like Upmap and the balancer and all these things, there's no way for us to force the data back to where to do any kind of tricks in that scenario. We have other um, solutions for that, doing that progressively. They're all relatively painful, but there are like fixing that in a very elegant, smooth, transparent way requires a new feature that we've designed in the upstream Ceph developers. It requires us to somehow enable a concept of slowly transitioning from one crush map to another. And it will be like you put a weighting value, you reweight a crush map. Basically, we go from crush A to crush B, but like we start with 100% A, go to 0% B, and like we slowly move the slider so that randomly we're flipping coins and we're deciding which crush map to use until we get all the way to B. This is a design. This is like in theory we know how to do it, but there's no code yet for that.
I want to demonstrate really quick how like it won't let you violate like a
exactly.
So like say if we tried to put all 3 of these OSDs onto Ceph 3. So like say we want 13 to move to 24, 35 to move to 25, and 31 to move to 26. It says it's going to do it, but it never does it. Does it even respond with an error?
It usually doesn't.
Nope. So it's just transparency fails.
Yeah, you only find it in the MON. The MON log says removed invalid upmap rule or something like that. Yeah.
Yep.
So that's a usability issue. Yeah. But again, it sounds like a lame excuse. These tools are developer tools. That's the whole problem. So they're not very usable. The goal is that the balancer itself just there's a set it and forget it, and that works out, right? So when is Upmap-remapped? Like everyone's heard of this tool, Upmap-remapped, and there are others like a PG remapper, I think, tool.
Yep.
Right, and there are tools like this. Like, what do they do? What's their purpose?
To kind of create these upmaps, usually to say make the cluster healthy. Like, let's do a quick example. Yesterday I marked out this OSD 33, just so to demonstrate this, like kind of like a cluster expansion example. So say if we do Ceph OSD crush reweight OSD 33, and we want to make it the full weight, you end up with a whole bunch of PGs in a remap state. But say you didn't want that to, be backfilling for a while, like maybe it's creating a lot of load on your cluster or something like that. What you could do is you could just use Upmap-remapped. I'll run it without typing into SH first to kind of give you an example. But it's going to create a whole bunch of different upmap items saying, stay where you currently are. So just run this, pipe it to SH. And you should start seeing all of these remapped PGs go to active clean.
Yeah. And we do this because Like why did we even invent this concept? It's like, this is the hard, sometimes I've given several presentations about this, and somehow this is the little trick, like what is kind of like understanding what is the purpose of this whole thing that we're doing is something that I sometimes have to give a few examples, right? So for Brian, like for you, why, in which cases operating a Ceph cluster do you use this one? So you're showing like you're adding an OSD, but like why wouldn't someone just add the OSD and
Like
give it its weight?
say if I'm adding an entire rack of servers to a cluster that's like already like 4 racks. I don't want to have all those OSDs like coming in at the same time, just because that's going to be a lot of backfilling traffic. So what I want to do is I want them to gradually come into the cluster. So I use Upmap-remapped to kind of say, stay where you currently are, and then we'll use the balancer to slowly kind of remove those upmaps to move the data gradually.
Yeah, because exactly. So if there's anyone that kind of doesn't, for which that isn't clear, like we can like throw a question in the chat, and there are no like we really want, like we talk about this thing all the time because it kind of like, it went, once we figured this kind of thing out in Ceph operations, it was a game changer for how we, for like our day-to-day work, wasn't it, Brian? Like,
Yep.
we used to, before this kind of tool, it was doing that kind of thing, like adding an entire rack to a busy cluster or removing an entire rack or busy cluster, was something that was very labor intensive, very scary, terrifying, right? Likely to be noticeable by users, latencies showing up, maybe like in the very old days of file store, like maybe OSDs flapping and things like this. So this was a way to just, like a puppet master, like control exactly and throttle, and have like a throttle, a gas pedal for like how fast and how slow we want to. Yeah. And like the base, yeah. Okay, go ahead. Yeah, sorry.
Oh, I was going to say, so if you notice, there's still a number that are remapped. What happened here is there's already